In this video, we're going to talk about what programming languages are. So let's start with a brief history of computing. The first computers were actually humans who manipulated mechanical devices, like the ones that's pictured here. That's actually Charles Babbage's analytical engine, and it was built in 1843 to perform a very specific calculation of one series of numbers called Bernoulli numbers that are calculated using a real specific mathematical formula that's complicated. And so this machine was built to do that precise calculation. A woman named Ada Lovelace was actually the one who designed the algorithm. So algorithmic computing goes all the way back to the 1840s, which is probably a lot earlier than you may have realized. And again, this would have been mechanical. There's no electricity here. This would have been, you can see the cranks and gears, but this is a computer with the idea that it performs calculations. So these early machines perform specific calculation tasks. So as you can imagine, this is built to do that one specific type of calculation. If you want it to do anything else, you would completely have to change, the parts of the machine. So you can see where it would be really hard to get these types of machines to do more than one thing. But these machines did enable iteration or complexity of calculation that would be difficult for humans to accomplish. One of the things that computers can do really well, even these super early ones, is to do the same thing over and over and over again with a precision that humans often can't accomplish, and with a volume that humans often can't accomplish, at least not easily. In the 1880s, the concept of storing data is introduced, and obviously that's a really big innovation. In 1906, a machine was built that actually could be retasked to a specific set of different jobs using something called a plug board. So it could do more than one thing. It still wasn't super easy to do lots and lots of things, not the way we think of computers today, but it could do multiple things. And then in the 1940s, IBM introduced the first electronic computers. So those would be really the precursors of the modern computers we have today. And that's the image here. It's an IBM 604, which is one of the first models of computer. And you can see, hopefully you can have a sense of how large that thing is. It probably would have stood about as high as you are tall or close to it. And you can see all of the parts in there. And it probably would have done a lot less than, even your cell phone that you have today. But that was one of the first electronic computers. So then what is programming? So we've talked a little bit about performing calculations and using machines to assist humans to do certain types of things. So when we get down to the nitty-gritty, though, programming is encoding a series of steps using a specific syntax, a specific type of language that has very strict rules that can be decoded and carried out by a computer processor to perform specific tasks. You can kind of think of programming as language that exists between humans and computers. One of the first types of programming in, again, modern electric computers was machine language. That is an encoding that uses protocols of a specific computer, because the machine language is people trying to talk to the machine in its own language, basically. It's the most basic form of programming that really attempts to meet the computer where it is in terms of communicating. Therefore, machine language is written in binary or even assembly language, which is a little step above binary, but it's not very human friendly. Just to expand on that just a little bit, because it's interesting, and basically, so everything in a computer at some point is converted into binary, right? Even today, we don't write in binary anymore, but the things that we do are eventually converted into binary and carried out in that way. So binary, as you probably know, is a series of zeros and ones, and those just represent sort of on and off states of something, right? And these collections of on-off codes correlate to really specific little bits of information or locations in your circuit boards to turn things on and off, and collected together. A long enough string of ons and offs can be decoded to do very complex things. Binary language usually comes in blocks of 8 zeros and ones. Those are like the basic units. So when you talk about a byte of information, you can kind of think of it that way. But there are loads and loads and loads of them to do even the simplest task, because you're describing something completely using just a sort of yes or no language. Assembly language, on the other hand, is a text format of binary language. So again, this is some attempt to make a language that's a little bit more friendly for humans. Assembly language does include some commands, but it also includes addresses. I did a little bit of assembly language programming a long time ago, and it used hexadecimal coding. So there were commands, but you had to convert them into hex code, and then you would use an address, again, that referenced a specific circuit location in the computing device. So assembly language, very specific to the exact type of machine that you're using. So you can see where, you know, it's powerful, it's fast, because you're speaking so directly to the computer almost in its own language. But it's very hard for humans, and it's specific to one type of machine. So it's not as flexible and therefore not as useful as the modern programming languages we have today. So I just want to give you a sense of what's happening a little bit under the hood and some of the phases that we went through in terms of trying to communicate with computers. Now, of course, compared to completely rebuilding a piece of the machine to do something different, as you would have had to do with something like Charles Babbage's machine, even assembly language is super user-friendly, but it is really hard to understand compared to the sorts of programming languages we have today. So today we have something called compiled languages, and that's what most programmers work in. So these are also called high-level languages because they're very far above that sort of binary level, to the point where they're fairly understandable for humans. And that's the point of them, is to make something that is more understandable to humans. They use syntax that's consistent across different devices. So instead of having to worry about what kind of computer you're using, you learn a specific compiled language like Java or C or PHP or whatever. So that's how we do it now, is the language functions across platforms. And it's really up to then the computer to do that work of turning it into the appropriate codes for that specific machine. So a different approach to computing these days. Now, obviously, the development of compiled languages made programming more powerful and flexible, and it's getting to the point where, you know, everyone is encouraged to learn some coding, right? So it's gotten to the point where it is considered easy enough that pretty much anyone can do it, and coding is becoming something that's sort of a standard in high school and that sort of thing. So it's reached a point of broad social diffusion. In particular, we are going to be working with object-oriented programming. So this is this is probably the most popular type of programming language, because it allows, again, very flexible, allows users to define data objects, and those objects can be fairly complex, and assign values, and then use functions to perform tasks. And we'll also talk about, you know, more specific terminology like methods and that sort of thing in a little bit here. The objects can be self-referential. So there is a sense of this or self as a concept within the language. So you can kind of point to the object. The object can point to itself and perform functions on itself. Object-oriented programming means that all of the items used in the program are identified with names, and sometimes those names are, you know, you could use pre-existing objects that are encoded in the syntax, and most of the time you can create your own objects and give them whatever names. And so that does make it a more human experience. This is really different than other high-level languages that were linear, that were based on, say, line numbers, and you'd point to different line numbers. So then if you put in a new part of your program, you'd have to look for all the references to those old line numbers and change that. I did some of that kind of programming too, way back when, and definitely it can be, you have to really think through where the pieces of your program are. With object-oriented, you don't have to worry about that, because you're giving things just names. And so wherever that is living within the code, as long as you call the right name and you've got that name correctly, the program can find it and can perform whatever function is being named. So object-oriented is the type of programming that we're going to be doing. And in particular, we're going to be using JavaScript in this class. So I wanted to just give an introduction to the syntax here. This is a line of JavaScript code, very simple. It starts, let's just look at each component for a second here. So it starts with a command. Then so that's basically the action that it's instructing the computer to take, the command. Then you see we've got some specific punctuation here for the parameters. So for now, you can think of parameters as just the information that a command needs in order to work. And again, we'll get into all that in more detail. But notice the parentheses and the semicolon at the end. Those are very important components of this line of code for it to function properly. And you probably remember from CSS, having that semicolon at the end is really important to making sure that's functioning. That's the notation for the end of a line. Then there's the value or the input. In this case, it is a discrete string of characters that spell out hello world with, you know, a comma and an exclamation point. So we're going to talk about string versus numeric data and values and get into all that. But that's it's sending one value, and it's marked with the open and close single quotation mark there, so that everything within that single quotation mark is the actual value that's being sent into that as a parameter for that command. And so this line of code is an instruction, right? As I said, that's going to tell the computer, the compiler, what to do. When it is run, and that's what we talk about, we always talk about running code, it will produce some sort of result. Now, as you can probably imagine, this is going to cause a pop-up dialog to open on the window wherever the user is, you know, one of those little gray boxes, and it will say hello world in it. So that's what that particular line of code will do. So that just gives you a sense, I hope, of programming in general, and then just a little bit of a taste of JavaScript syntax in particular. And we will continue in this module to introduce some of these top-level concepts that we'll be delving into in the rest of the term.